Hi, today I'll be explaining simple programs. Generally, we use these simple programs, Java programs, for creating logic for log analyzer and banking system with exception handling. Okay, I want to explain these two programs. Let's see, we can. So I'm going to create a simple log analyzer class file and main method. I'm going to create a hash map. You can see hash map map of integer string comma integer type. So key is the integer type, value is sorry, key is the string type, value is integer. And then you see I'm going to read app.log file. Okay, I have used files.read all lines, pass.get of passing the file name. So it will give all the lines. So this is the new approach of reading a file name. You don't need to open a file and don't need to use java.io. It is a simplified method. You can use a java.io, but here simplified single line where you can read the file. And I'm iterating the lines. You can see wherever the line contains a error tag, I'm going to take that. You can see I'm going to split that line by space. So my array of parts will contain all the words in a particular line. I'm going to pull out at the index the word at the index 2. So 0, 1, 2. So it will be the error type. So I'm going to get that error type and I'm going to put the error type as a key into my hash map and error type how many times the error type is getting repeated. I'm counting it, you can see here. I'm just counting it how many times that kind of error type is repeated. So the hash map will contain the error type as a key and the value is the number of times the error type is repeated. So I'm going to iterate the error count map using a for each method. You can see I have used functional programming style here. Java 8 I have iterated it. Now we can iterate that and you can see that there. I'm printing how many times the error type k and value occurred, how many times the error type is occurred. This is a simple log analyzer. Generally in real world applications, for finding out the multiple errors we will see and we will face. So to find out the specific errors and how many times they are occurring, we want to know that, right? So this kind of logic would be helpful to figure out. So you can see bank system with object-oriented programming, exception handling. How do we handle exception handling? Okay, you can see here. First thing is I want to create a bank account. So inside a bank account, I will have a balance attribute, private double balance attribute. I declared it, and a constructor inside that I'm passing initial balance. Okay, integer data type is double, and after that I have created a method to withdraw. So here I declared a throws exception, throws insufficient balance exception. It is a custom exception. So you can see where is the custom exception. I have created a custom exception here. Class insufficient balance exception extends exception class, and I have created a constructor passing an argument using a super method. So it is that way we can create a custom exception by extending exception class. And then what I am doing here, whenever you withdraw amount, you see balance equal to balance minus amount. Okay, the amount value will be subtracted from the remaining balance, so that will be the remaining balance. For deposit, it will be addition. You see balance equal to balance plus amount. This is a general basic logic whenever they are implementing the banking application for withdrawal deposit application. You see two methods. So many functionalities are there, but we are seeing only deposit and withdrawal functionalities here. So in the main class, you can see I'm passing 1000 rupees in the constructor as the initial balance. So 1,000 rupees. After that, what I'm doing, I'm trying to withdraw 1,200 rupees. There is a problem here. I'm having only 1,000 rupees, but I'm trying to withdraw 1,200 rupees, which is insufficient balance. So it will definitely throw an exception. That is why I have created a insufficient balance exception custom class. Okay, we have a custom class. Then what happens here? So expression will be caught by this catch block, and it will print the error message. That way we can handle the exception classes. Basically, you can create a custom exception classes here. That is a good thing. You need to remember one thing. Whenever you are creating any Java applications, you have to create a proper custom exceptions. That way, so exception message will be very clear and understandable to the client. Otherwise, it would be difficult. If you are using null pointer exception, SQL exception, or IO exception, file not found exception. So if you are using built-in exceptions, sometimes you don't know where exactly the exception is coming. So you should declare a meaningful exception classes, that custom exception classes. That is the standard programming approach. Whenever you are going to create a standard programming, I mean creating any enterprise applications, you need to follow these standards and all. Okay, I hope you get that. And okay, there are complex things you can see here. Implementation, custom thread pool implementation. Okay, here you can see using a runnable interface. Uh, they are creating a uh, custom what is the custom thread pool. So generally, concurrency is a concept where multiple threads perform tasks concurrently, right? You can see here thread pool example class, simple thread pool. We created a class, custom class. You can see here. So inside that, what I am going to create pool.execute of, and just printing the executing task, I mean thread name. So how it happens, you can see we declare two variables, blocking queue of type runnable interface, which is taking a runnable interface as a get type as a parameter, and thread string, worker string of thread type. So what I'm doing here, declare the pool size. Okay, thread pool size. Where is the pool size attribute? I'm passing this pool size. You can see it is 3. And linked black in queue. I have taken, no, they have taken a linked black in queue here. So we are iterating is a for loop. Now you see here what is workers. Workers is this array of thread type. Now I'm going to assign threads here in the array. Okay. So workers of I equal to new thread of. So inside that, it is anonymous block. I'm going to write functional programming style. You can see here. Inside that, I have a while loop, and I'm going to create a runnable inside try block. Runnable task equal to q dot take task dot run. It will instantiate a new thread, right? And also you can see below workers dot I of start. It will start the basically run method. Task dot run method is the method where thread performs particular certain task. So the thing is, we are creating pool size of 3 threads here and assigning all those threads to workers linked array of type thread. Okay, so that way it will execute the thread. Okay, it will execute the thread. We can see here. I'm going to give a task number here for int I equal to 1 I less than or equal to 10 I plus plus. Int task number equal to I. Okay. Now pool dot execute. What it will do? It will execute that method. So let's say, uh, but maximum size of simple thread pool is 3. You can see pool size workers is 3. For every task, 3 threads, right? For every task, this 3 threads will run parallelly. I think this is the program. Okay, the concept of this program is it will create a task number. You can see for loop, we are iterating for loop for int I equal to 0, I less than or equal to 10, I plus plus. Executing the task 1 by thread name. So for every task, I think it should print 3 times, right? Because 3 threads are there. Maximum thread pool equal to what is that size? Pool size is 3. So this is how custom thread pool implementation can be achieved. Okay, I hope you got this thing. Okay, and there is least recently used catchy implementation. Least recently, what is least recently? We have used these algorithms, right? Some round robin algorithm. Least recently, uh, most recently used, least recently. I mean, how less? Uh, you may use something. So design last least recently used catchy. Let me explain this. I'll try to explain. So first jump to the main class here. What we are doing? We are creating LRU catchy, and it is a hash map of integer. Key is integer type and value is string type. Size is 3. Okay, but the thing is, first I'm going to put 1 comma a. Key is a 1, value is a. That is the first entry. Next entry is the catchy dot put of 2 comma b. Catchy dot put of 3 comma c. Now three values are have placed. I think catchy must be full. Then I am going to get another value. See, catchy dot get of 1. Okay, and after getting that, so one entry is empty. Now I am putting again another empty fourth entry. And after that, I am printing. It should print again only 3 attributes. But the thing is here, you can see it should. Uh, you can see dot get what it will do. We have a method. You can see in the main class, class LRU catchy. It is extended linked hash map. And constructor LRU catchy int capacity. It is taking int capacity maximum 3. It will set the 3 capacity value. And protected boolean. Remove eldest in 3. Remove eldest in 3. Okay. Uh, map dot entry k comma eldest. It is taking eldest. Return size of the method is greater than capacity. Eldest youngest. What is the eldest entry? Eldest entry is 1 comma a, right? It should be 1 comma a. So the program will remove the 1 comma a. So I think it should print 2, 3. Catchy will contain of the values, key values like 2, 3, 4. We should remove the first value and last value as per this program. So this is how the least recently used catchy. It is a catchy implementation. Okay, and one thread produces data, another consumes using wait notify. Okay, this is also shared buffer concept. One thread produces data, another consumes it. Problem. Okay, using notify. So here concepts you see here, we have a producer method, consumer method. All these methods should be declared synchronized. because this is a threading application, right? Synchronized keyword, you can see that there. And producer, we are creating how many threads? We are creating a 5 threads here. Consumer also, we are creating 5 threads. So buffer dot produce of I am passing I value, first value. The producer will take a value. While of has data, it will be false because initially has data declared false, boolean variable declared as a false. It won't go there. Data will be set as 1. Has data true and making it true, then it will print the value produced value 1. And after that, I'm notifying it. Notify what it will do. The notify. Okay, it has to. I think. What is the one through produce data another consumer using it. So consumer, it has to notify the notify method. So I think it has to. Yeah, I think it. Uh, Next thing is, so 5 producers will be created, 5 consumers will be created. When you call wait method, it will wait. You can see in consumer class while has data, I mean it is true. I'm calling a wait method. Okay, and after that, when you call a notify method, it releases the thread basically. I think once the value is produced, the consumer has to read the value. That is the logic here. Okay, the consumer will read the data produced by a producer method. Let's say initially it is setting a value 1 and the consumer will read that value. And for the producer is setting a value 2 for the next iteration, consumer has to read the value. So these are the logics. These are kind of complex logics. I just wanted to discuss. I hope you understood this. Thank you very much.